Hello everyone, good evening. So here in this video, we shall solve some previous year KCET questions on the chapter Ray Optics and Optical Instruments. So in the previous part of this chapter, we had solved till question number 19. So in this second part, we shall solve from the question number 20 onwards. So any doubts if you have in any steps of the solutions, then please write that in the comment section. And if you feel more difficulty in any of the chapters of physics, then please mention the name of that chapter in the comment section. Some important homework questions on every chapter will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here we shall start from the question number 20 onwards. So it has been told the time required for the light So the time required for the light to pass through a glass slab having refractive index equal to 1.5 of thickness 4 millimeter is c equal to 3 into 10 power 8 meter per second speed of light in free space. So the time required is the distance by the speed. So the speed in the glass slab will be equal to c by mu, where mu is the refractive index of the glass. So this will be the thickness d by c by mu. So that is mu d by c. Therefore, the time required, that will be 1.5 into thickness, that is 4 millimeters. So 4 into 10 power minus 3 meter divided by c, that is 3 into 10 power 8. So this much seconds. So if 1.5 into 2 is 3, then it is 4. So 2 into 10 power minus 11 seconds. So option B is the correct answer. Then a prism having refractive index 1.414. A prism is having refractive index is 1.414. That is root 2. And refractive angle is 30 degrees. As one of the refracting surfaces silver, a beam of incident light on the other refracting surface will retrace its path with the angle of incidence is. So it will retrace its path if the falls normally on the second surface, since if the second surface is silvered. So this is 90 degree. This is 30 degree. So this should be 60 degree. Means that here the angle of refraction should be 30 degree. Here the angle of incidence is high. So therefore, angle of incidence is how much, that is asked. So here if we apply the Snell's law, then outside there is air. So that is refractive index of air is 1. Refractive index of air into sin I, that is refractive index of glass of the prism into sin 30 to sin R. The angle of refraction is 30. That is 1 into sin I, that is equal to root 2 into sin 30. Sin I is root 2 into 1 by 2, so that is equal to 1 by root 2. So I is equal to 45 degree. So option D is the correct answer. Then in question number 22 it is told a plano-convex lens has a maximum thickness of 6 centimeter and placed on a horizontal table with the curved surface in contact with the table surface. There is a plano-convex lens. It has maximum thickness of 6 centimeter placed on a horizontal table with the curved surface in contact with the table surface. So it is placed on a table, it is curved surface on the table surface. The apparent depth of the bottommost point of the lens is found to be 4 centimeter. If the lens is inverted such that the plane face of the lens is in contact with the surface of the table, the apparent depth of the center of the plane face is found to be 17 by 4 centimeter, the radius of curvature of the lenses. So in case of the refraction, so this is case 1 and this is case 2. This is case 2. So suppose the refractive index of the lens is mu and outside there is air. Outside there is air, the refractive index is mu. So for the case 1, we have the point O is the bottommost point. So here we can say that we have to apply the rule for refraction at a spherical surface. That is mu2 by v minus mu1 by u, that is equal to mu2 minus mu1 by r. So here the light ray is going from the lens to the air. So it means that mu1 is that of the lens, refractive index of the lens, it is mu, and u2 is that of the air, that is 1. So this will be u2 by v minus mu1 by u. Here it is told the maximum thickness. The maximum thickness is here, this is 6 centimeter, which is u. U is minus 6 centimeter. V will be it is found to be at a depth of 4 centimeter. So V is minus 4 centimeter. This is minus 4. And you know, this is mu by minus 6. That is equal to 1 minus mu by r. R is infinity. It is minus 1 by 4 plus mu by 6. It is 0. Mu by 6, that is equal to 1 by 4. So mu is equal to 6 by 4. That is 4 to 3 by 6. And mu is equal to 3 by 2. So the refractive index of the lens is 3 by 2. And then for case 2, it is the light ray is going from lens to the outside, lens to air. So here also mu2 by v minus mu1 by u, that is mu2 minus mu1 by r. So here the apparent depth is 17 by 4 centimeters. It means that v is minus 17 by 4 centimeter, and u is, this is 6 centimeter. U is minus 6 centimeter. Here we should take r, actually this way to take it as minus r. The radius of curvature should be minus r, since why the center of curvature is on the negative side. Therefore mu2 is here, mu1 is the lens, that is mu. So mu1 is mu, that is 3 by 2. This is 1 by minus 17 by 4 minus of mu1, that is 3 by 2 divided by u, that is minus 6. That will be equal to mu2 1 minus by r. That is minus r. Plus that is 3 by 2 into 1 by 6. This is equal to 1 by 2r. 1 by 4 minus 4 by 17, that is equal to 1 by 2r. So then 17 fours are, that is 68, and this is 17 minus this is 4 fours are 16, that is equal to 1 by 2r. So 2r is equal to 68. So r is equal to 34 centimeters. So the radius of curvature is 34 centimeters. So option D is the correct answer. Then in question number 23, it is told two thin lenses of combined power of 9 diopter. When they are separated by a distance of 20 centimeter, the equivalent two thin lenses are there. Their combined power, so 1 by f1 plus 1 by f2, that is 9. And they are separated by a distance of 20 centimeter, then their equivalent power becomes 27 by 5 diopters. So when they are separated by a distance d, then 1 by f equivalent, it is equal to 1 by f1 plus 1 by f2 minus d by f1 f2. Therefore, this is the equivalent power in this case, which is okay. So this is 9. Therefore, P1 plus P2 is 9, and this P1 plus P2 plus minus D into P1 P2, that is equal to 27 by 5. So therefore 9 which is 9 minus D is 20 centimeter, 20 by 100 meters into P1 P2, that is equal to 27 by 5. So therefore, since P5 is 100, so this is P1 P2 by 5, that is equal to 9 minus 27 by 5, P1 P2 by 5, that is equal to 5 nines of 45 minus 27. This is 8, which is 18. 18 by 5. So P1 P2 is 18. So in only one of the options, the product of their powers is coming 18. That is option C. 3 6 18. 1 8 8. 2 7 14. 7 4 5 20. So only in option C, P1 into P2 is coming 18. So option C is the correct answer. And if the scattering intensity of a liquid is 8 units at a wavelength of 500 nanometer, then the scattering intensity at a wavelength of 400 nanometer will be approximate. If the scattering intensity of a liquid 8 units, the scattering intensity of a liquid is 8 units at a wavelength of 500 nanometers, then the scattering intensity at a wavelength of 400 nanometer will be approximate. So we know that intensity is proportional to 1 by lambda power 4. So it means that I1 by I2, that is equal to lambda 2 whole power 4 by lambda 1 whole power 4. So therefore it is told that at lambda 1 equal to 500 nanometer, the scattering intensity I is 8 units. I1. And so that this I2 will be how much when lambda 2 is 400 nanometer. So therefore here I2 has been asked. So I2 will be actually lambda 1 by lambda 2 whole power 4 into I1. So therefore I2 that is equal to lambda 1, that is 500 nanometer divided by 400 nanometer divided whole power 4 into I1. I1 is 8, so this much units. So this will be 5 power 4, 5 5 25, so this is 625 divided by 4 5 16, 16 into 16 into 8, this much units. This will be 8 to the 16, so 32. So 32, 625 divided by 32, that is 32 on the 32, 305. So then 32 into 9, 2 9 is 18, 3 9 is 27, 28, so 9, so it is 19 point something. So this is approximately 20 units. So option C is the correct answer. Then in question number 25, it is told a point source of light is kept above the surface of water at a depth of is kept below the surface of water at a depth of √7 meters. Here one point source of light is kept. The radius of the circular bright patch of light noticed on the surface of water is. We have to find the radius of that bright circular. The radius of that bright circular patch radius of this bright circular patch of light noticed on the surface of water. So this radius is how much? So here actually we should use the concept of the critical angle of refraction. So here the critical angle is how much that we have to find. So this is theta c, suppose, which is the critical angle. I can say that it is IC. IC here it is the critical angle of incidence. So here the angle of refraction will be 90 degrees. So therefore here you can say that refractive index of the water is 4/3, and refractive index of the air also, that is 1. So therefore I can say that refractive index of water into sine IC, that is equal to refractive index of the air into sine R, sine 90 actually. So therefore sine IC, that is equal to 1 by n W, that is 4/3, that is 3/4. Therefore the critical angle IC, that is equal to sine inverse of 3/4, sine inverse of 3/4. Now therefore from here this radius is the depth. Let this depth I can call it as d, suppose. So this is also d. Therefore by using this right angle triangle we can see that this this is also R, this is also d. This is d, this is R. So from here you can say that tan IC is also IC. So tan IC is R by d. So R equals to d into tan IC. Now from here sin IC is 3, so therefore tan IC, then equal to sin IC by square root of 1 minus sin square IC, that is 9 by 16, square root of 1 minus 9 by 16. So this will be equal to 3 by 4 by, this is 7 by 4, root 7 by 4. So this is root 3 by root 7. So this will be root 7 into 3 by root 7. So that will be equal to 3 roots. 3 meters, or 3 meter is the radius of that circular bright patch. Option B is the correct answer. So hope you have understood the solutions of these questions. So in the next part of this video on ray optics, we shall solve from question number 26 onwards. And any doubts if you have, then please write us in the comments section. And install our Sapience Education application, where we shall upload some important homework questions on every chapter. Thank you everyone.